Class, welcome back to another video about triangles. Everything you ever wanted to know about triangles. Alright? Maybe not everything, but quite a bit. This video, I will tell you, is going to be a little bit longer than I want, just because there's a lot of notes and a lot of stuff to cover, but I don't think the material is going to be challenging. You just got to stay with me. Alright? So I will try to go quicker than normal. We'll see how I do. Alright, so an acute triangle. I'm hoping you guys know some of this already. An acute triangle, something like that maybe. All I need to know when I have an acute triangle is that I have three acute angles. And if you remember, acute means less than 90 degrees. Alright, so we need to have a triangle that ends up having three acute angles. Now an equiangular triangle, keyword kinda, or key like little part here, the equi, that means equal, alright? So when we do this, we need to have three equal angles. So I'm going to try and draw this a little better, something like this. Now because they're equal angles, I know for a fact that I can do some of that. So now it turns out that this is going to be three congruent acute angles. And what's even cooler, guys, we know no matter what, always, whenever you have an equiangular, and actually equilateral too, that we'll get to in a second, but this will always be 60 degrees. Must be 60 degrees. 60 plus 60 plus 60 is 180, and that is what you need to have a triangle. Alright, so there's that. Then we have a right triangle. I think you guys probably know this one. Something like this. All that we really need is that. One right angle. So, one right angle, which is good to know. And then an obtuse triangle. Something maybe like this. And we know that we have one obtuse, or greater than 90 degree angle. Okay? So those are the types of words I would be looking for if we're classifying triangles by angles. Acute, equiangular, right, obtuse. Now if we go and we want to classify by the sides, by the sides, we have different words. We have equilateral, isosceles, scalene. Now equilateral is going to look really similar to the picture I drew before, but now I know that all the sides are congruent, okay? Equilateral means equal sides, three congruent sides. Now I'm going to add to this picture what I drew for equiangular so you understand that that is also true, okay? Equilateral and equiangular are going to be the same, alright? And we'll get there in a little bit. An isosceles triangle, if you guys remember, looks maybe something like this. What's super important about that is that it has at least two congruent sides. And then a scalene, and actually, you know what, I should do one more thing on this. I'm going to make sure, you know what, no, scratch that off. Scratch that off. Let's just stick with this for right now. I'm sorry about that. For a scalene, maybe something like this, where I have 1, 2, 3. So 0 congruent sides. The reason I got rid of this, guys, is because it is at least 2. Technically, you can call an equilateral triangle an isosceles triangle. So this doesn't necessarily have to be different than this one. It just turns out that normally it does. But I should be specific and exact and correct in my video. All right. So there are our three types of classifications for triangles by their sides. And now we move on to focusing in on isosceles triangles. All right, I'm going to draw one, a nice big isosceles triangle. I know it has that, two congruent sides. And we're going to label some things, okay? So the legs of an isosceles triangle are the congruent sides. Oh, I can't spell. Congruent. Sorry about that. So this is a leg, and this is a leg. All right. Vertex angle is the angle formed by the legs. So right here, that's our vertex angle, vertex angle. The base is the side that is opposite the vertex angle, okay? So if this is my vertex angle, what's opposite? Down here, this is the base. And then base angles are the two angles that have the base as a side. So this is a base angle right here. This is a base angle, and I'll kind of point to these right there. These are the base angles. Alright, so now that we have some ideas about how to label an isosceles triangle, let's talk a little bit about some theorems that we know about isosceles triangles on the next page. So if we come back up to the top here, okay, so isosceles triangle theorem. If two sides of a triangle are congruent, then the angles that are opposite those sides are congruent. All right. So what I'm going to do here is I'm going to draw a little picture. I'm going to call this A, B, C, and I'm going to say that AB is congruent to BC. All right, so there's my picture, and what I want to conclude, guys, is that the angles opposite the sides are congruent. Okay, so if AB is one of the sides, what's across from AB? C. What's across from BC? A. So my conclusion is that angle A is congruent to angle C. All right, that is what we are looking for. Now, it works the same, but kind of in reverse. And actually, you know what? I'm going to mark that just so you have it now. Now we know that that is true. All right. Now, again, it works the same in reverse. If two angles of a triangle are congruent, then the sides that are opposite, those angles are congruent. So really, guys, I want you to use the same exact picture, but instead of saying AB is congruent to BC as our starting point, we're saying that A is congruent to C, and from A is congruent to C, we can go back and say now that AB is congruent to BC. Okay, so the only difference is what I'm giving you. In the first example, I'm telling you that the sides are congruent, so you're getting that the angles are congruent. In the second one, I'm now telling you or giving you that the angles are congruent, and from that, you can get that the sides are congruent. One thing that we are going to see on the next page is explanations, and what I mean by that, we're just going to draw little pictures. In this case, I gave you sides, and we got to angles. So if I give you sides are congruent, then angles are congruent. I know that's kind of tiny, but hopefully you can see what I did. And now in this one, it's the opposite. If angles are congruent, then sides. All right, and so that's a really nice way of just explaining how that works. All right, almost done. Oh boy. Okay, if a triangle is equilateral, then it is equiangular. Angular. Also, if a triangle is equiangular, then it is equilateral. All right. I don't necessarily think I need to write this. I mean, I guess, yeah, let's do it. Why not? All right. If I give you A, B, C, and I tell you all the sides, well, then what can we say? We can say that angle A is congruent to angle B is congruent to angle C. And why? Because if equilateral, then equiangular. All right? Oppositely, or conversely, I should say, if I give you A and B and C are congruent, then we can say that AB is congruent to BC is congruent to CA, and my reasoning would be if equiangular, then equilateral. All right? So this is a good page to kind of keep in mind and practice. Now, oh my gosh, 10 minutes in already? Whew, almost 11. All right, let's try and go through some of these. I might skip a little bit and do some more in class, but let's at least get through some of this classifying and maybe a problem or two so you can see what's going on. Okay, up at the top. Classify the following triangle by their sides and angles. Sides and angles. Okay, sides first. Two congruent sides, isosceles. Angles. Acute, 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 no obtuse, no right. Okay, this is acute. Right? Correct. How about this one? No sides the same, so scalene. A right angle. Right triangle. Easy enough? Last one. No sides the same, so scalene. Angle, no congruent angles, but one of them is obtuse, so the triangle is an obtuse one. All right? Honestly, I think that should go pretty easy for everyone. Let's take a look at something like number 4. All right, in number 4, it says find the side lengths in the following triangles. Now you need to be real careful here. You can't just pick anything and set whatever you want equal to each other. You have to look at the tick marks. I know that this side is congruent to this side because it's an isosceles triangle and because of the tick marks, the congruency marks. So I know that LK is going to equal JK, or x plus 3.2 is equal to 4x minus 1.3. Now if I solve this, I'm going to move the 1.3 over, so x plus 4.5 equals 4x. Then I can move my x over, so 3x, x equals 1.5. Now please be very careful. Does it say to just find x, or does it say to find the side lengths? It says to find the side lengths. So we use this 1.5 to help us. JL is going to equal 5 times 1.5 minus 0.2, or what is that, 7.5, so 7.3. LK. LK is x plus 3.2, so 1.5 plus 3.2 equals 4.7. Great. JK. Do I need to do any work? No, I do not. JK has to be the same as LK. JK equals LK, which is equal to 4.7. And we're done. All right, so that is good. I'm going to skip 5 for now. I think you guys, if you want to try 5, go for it. If not, we can do it in class and we can check. 6, I do want to do just because it is a word problem, and I know word problems freak people out. So here we go. A manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. Okay, equilateral triangle. Good. How many 4-inch triangles can the manufacturer produce from a 100-inch? Okay, so 4-inch triangle probably means that each side is 4, which means the perimeter, or adding all of them up, is 12 inches. Now, if you have 12 inches for one triangle, and you have 100 inches, what are you going to do to kind of figure this out? Let's divide. Okay, 100 inches divided by 12 inches equals, what is that, 8? 8 point, let's just reduce. So 50 over 6, 25 over 3 equals 8 1/3. Okay, so you guys can absolutely use a calculator. I just don't have one with me. I would want you to say and understand that this is a real world example, like this is an actual thing being produced. So we wouldn't say that you could make 8 1/3 triangles. You would just say 8 triangles. All right. Do I stop there? 15 minutes. You know what? I want to do one more problem. And I know I'm going over my time. I want to go over number 8 just because this is an equilateral triangle and it's something that I want you to kind of see what I mean by this explain part. Okay? All right. So in this picture, we have an equilateral triangle, which means we know that every angle should be 60 degrees. All right? And if that's the case, then I can say that angle C has to equal 60, or 3x plus 15 has to equal 60. So 3x is equal to 45, x equals 15. All right? So I put 15 for x. Measure of angle B, do I have any other work to do here? No, I don't think so. I think I would just say that this is 60 degrees. All right? Now on this one, for an explanation, what I'm really looking for here, guys, is it did not tell me anything about the angles to start. How did I get there? Or what did it start? What did I start with? I started with sides. I had 3 congruent sides, which means if I have 3 congruent sides, it's an equilateral triangle, and if a triangle is equilateral, then it is equiangular. So the only thing I need you to really write for an explanation here, guys, is how you got to this part right here. How did you know that angle C had to be 60? Well, that was because if equilateral, then equiangular. And that is really all I'm looking for explanations. All right, I think that's a good place to stop. I'm sorry, I know this took a lot longer. To be honest, this is better than I was anticipating. I thought this was going to go like 25 minutes. So I hope that you guys are understanding this stuff. We are going to have lots and lots of practice time on this because I know it's a lot of material and it's pretty important. This is stuff that we really like you guys to know just for problem solving purposes. But I will stop talking now. I hope you have a great day. See you next time.